Alright, let's talk about matrix and determinants. So matrix is basically a two-dimensional set of numbers or functions, and these numbers or functions are arranged in horizontal rows and vertical columns. In the given matrix, we have 3 rows of elements and 3 vertical columns. And with this, we can define the dimension of matrix, also called the order of matrix. It is the rows times the columns. And we have 3 rows and 3 columns for this matrix, so the order is 3 by 3. Now let's see what are the order for the following matrices. So for matrix A, we have 3 rows and 1 column, so the order is 3 by 1. For matrix B, we have 1 row but 3 columns, so the order is 1 by 3. And for matrix C, the order is 2 by 2. And now let's see the matrix elements. Well, we already know now, matrix, it has numbers or functions. And for any given matrix M, the elements can be represented as shown on the bottom right. So element M sub 1 1, what it means. So M sub 1 1, sub 1 means row 1 and next index is column 1. So it means M sub 1 1 is the element from row 1 and column 1. Similarly, the next element M sub 2 1 is the element from row 2 and column 1, which is -4 for the given matrix M, and so on and so forth. Now let's see the different types of matrices. So we can have a row matrix. Its order is 1 by 3 because we have 1 row and 3 columns. Similarly, we can have column matrix, just single column, and its order is 3 by 1 because 3 rows and 1 column. We can have null matrix, right? If all the elements are 0, we call it null matrix or 0 matrix. And here, for example, I've taken 3 by 3 matrix. It can be 2 by 2, it can be 4 by 4, and whatnot. Similarly, here I saw next example as diagonal matrix. If all the off diagonal elements are 0, we call it the diagonal matrix. And for the same diagonal matrix, if all the diagonal elements are same, we call it scalar matrix. And if all the diagonal elements happen to be 1, we call it the unit matrix or also the identity matrix. So these are just general examples, and there are many more. Now let's talk about the addition and subtraction of the matrices. How can we add them and subtract them basically? In order to add and subtract the matrix, the order of the matrices must be same, or else we don't know which element from a given matrix should be added or subtracted to what element from the next matrix. So for the first set of matrix, the order of both matrices are same, so we can basically add them. But for the second set of matrix, we can see the order is not the same, so we cannot add them because we don't know which element gets added to what element from the second matrix. And here, for the first set of matrix, since we can add them because their orders are same, so if their orders are same, we can basically add elements relative to their position. So the element from first row, first column of the first matrix is added to the element, the first element, which is element from first row, first column in the second matrix, and so on and so forth. For the second set of matrices, we cannot add them because their order is different, and the same story with third set of matrix. All right, now let's talk about the multiplication. For multiplying matrix, it is guided by one set of rule. The columns in the first matrix must be equal to the rows in the second matrix if we want to multiply two matrices. For example, here in these given set of matrices, so the first matrix, its order is 2 by 3. It has 3 columns. For the second matrix, its order is 3 by 2 and it has 3 rows. So the rule says the columns in the first matrix should be equal to the rows in the second matrix, which is what we have here. So basically we can multiply them, right? Now the question is, what would be the order of the resulting matrix? So the order of resulting matrix would be the rows in first matrix times the columns in the second matrix. So in this example, the order of the resulting matrix would be 2 by 2. Okay, now let's do the actual multiplication of these two matrices. Okay, so whenever we are doing the multiplication, right, we always go from rows to columns. Okay, so step 1, so we take the first row from first matrix and multiply it with the first column of the second matrix, and the result is 28. Similarly, we multiply the first row from first matrix with the second column of the second matrix, and the result is 103. And as the next step, we multiply the second row of first matrix with the first column of the second matrix, and so on and so forth. And the result is a 2 by 2 matrix shown here. All right, so let's do a few more examples. So let's multiply a row matrix and a column matrix. The first thing we need to look for is, can we multiply them? And we can definitely multiply a row matrix with a column matrix because the number of columns in the first matrix is equal to the number of rows in the second matrix, right? Which is 3. We can multiply them, right? So it's okay. And what about the order? Well, the order is rows in the first matrix times the columns in the second matrix, right? Which is 1. So the order is 1 by 1 basically. And if you multiply them, we end up getting 20. Well, it kind of matches our prediction, right? The order should be 1 by 1, which means 1 row, 1 column, 1 element. What about the second set of matrices? I just flipped how they are positioned. Now we are multiplying column matrix with the row matrix. Can we multiply them? Yes. Once again, we can multiply them because the columns in the first matrix is equal to the number of rows in the second matrix. But what about the order? It's 3 by 3, right? And if we multiply as we did in example 1, then we end up getting 20. But the order is not correct, right? We should be getting 3 by 3. So the first one is correct, the second one is not correct. Okay. How do we do then? So, well, we can basically follow the rules. To multiply the matrices, we should take the first row from first matrix, multiply it with the first column from the second matrix, and so on and so forth. And we end up getting a 3 by 3 matrix. Alright, so what do we learn here? Is multiplying matrix A with B is same as multiplying matrix B with A. Think about it. Alright, so in conclusion, what we did was we just went through matrices. What are matrices, right? These are basically the two-dimensional set of numbers, and we saw how we can add them, right? And subtraction is just basically adding the matrices, just flipping the sign, right? And matrix multiplication, well, one rule to keep in mind is the columns in the first matrix should be equal to the rows in the second matrix, and the order of the resulting matrix is equal to the rows in the first matrix times the columns in the second matrix. Yep,